All right. So today is the last of the three things. Remember to reiterate. I said I don't care if you're not going to listen, but you're not going to interrupt me. And I have the attention span of the common housefly. I have ADD. So if you're talking in the back because you don't care about anyone else's education, then I cannot teach. So zip it. Hey, that's a great intro. Good morning, everybody. Okay. All right. Now, so as I was saying, got a little thing going on in my chest here. Three things the last, 2 days plus this one. They all stick out like a sore thumb. They are all so unique, so different. You're given the formulas on a formula sheet. The formulas will be obvious which ones to use. For some reason, today's situation is back to a Z distribution. So you don't have to do the T-chart looking up stuff. Look at the bottom of your sheet that I gave you yesterday, right? And I cut a clip of it. There is a problem. I will tell you that. And you should know what I'm talking about, but I know a lot of people might forget this. One of the questions on your worksheet, it's actually number 4, asks for an 86% confidence interval or level. And that's not on the sheet. So what you have to do is go to your other Z chart and do what we did on Tuesday at the beginning of Tuesday's notes. And if you want to look at the beginning of Tuesday's notes video to see that like 3 times, and plus the guy that I showed you on Tuesday did it once, then you go ahead and do that. All right, maybe I'll have time in class to hit number 4 before we leave, and we can hammer that down. But anyway, what's population proportion? Or what is a proportion in general? As this scrolls down, at the end of this sentence, it's the presidential approval rating thing I had mentioned before. It is, okay, I polled this many people, and they had that 40% of them approve of the president's job. What does that mean, disapprove? How many disapprove? 40% approve? Or it could be, 58% disapprove and then 2% declined, like they're either or. Sometimes it's approved, disapproved. But in this case, that doesn't work. I'm sorry, that's bad. It's either one or the other. So 40% approve, so therefore 60% disapprove. So that's what this will emulate itself as. It will be presented as a percent or a decimal, or it will say, 34 people out of 100 sampled believe in this. Well, then therefore it's a proportion that we're dealing with, and therefore the formulas that I'll show you coming up. That really should make sense. So what's the population proportion? Everybody's feelings. And we can't really know that unless we say, for the president example, we asked every single person that's involved. And even kids, even though they can't vote, the kids can have a feeling. Most of you in here can't vote, but you also can have a feeling about the president. So just imagine a task it would be to get that whole population's feeling. So what do we have to deal with? A sample. And from that sample, try to make a conjecture about the whole population. That is the basis of statistics. Look at this weird thing. This is P hat. Yes, it is. And what's on top of that P is like this thing. It's like with a corner on top of it. That is called P hat. Believe it or not, that's why I put that in parentheses right here. And that represents the fraction or percent of the sample. So like I said, we poll 1,000 people. 1,000 people is the sample. And from that sample, we try to say something about P, the population's proportion. The whole idea of these confidence intervals, 40% of the sample feel this, they disapprove of the president. So then when we do a confidence interval, we can have a certain percentage of feeling that the whole population has a margin of error of, let's say, 3%. So we can feel P is between 37 and 43% approval rating. And that's the whole idea of a confidence interval. All right. So hopefully I can move to the next page freely. Good. All right. The next one is just the example that you can go ahead and write down. I'm going to try to pause. A customer. I don't even know if that could pause the video or not. I really don't. Back there, you know about this? Okay. All right. Sorry if this is on the video or not. This program limits what I can do. All right. I hit Control F9 again. I don't even know if the video is going or not right now. I have no idea. I'm not getting anything from this wonderful new computer. All right, anyway. What's the population, everybody? What's the population? 3,520. And it's those people. What's the sample then? What's the sample? How many people are in the sample? You're killing me, Smallses. Can anyone read? What number represents the sample to try to emulate this? No, the sample's 250. No one said that. Okay, now, what is P? Hi, caramba. What is P? What do I have to do? Who do I have to divide to get P? 1056 divided by 3520. How do I get P hat? Already? I can't pause the video. Are you kidding me? All right, and then what's P hat? What's P hat? 145 over 250. I don't get it. P is the whole population's proportion of people drinking Pepsis. The whole population, if it's 3520 and 1,056 of those drink the Pepsis, then that's P, the population's percentage of people drinking Pepsis. Pepsis? I love Pepsis, by the way. When I was a kid, I used to call it Peeps. I used to get made fun of. Because, I mean, come on, look at it. It looks like Peeps. Are we going to Peeps, Mom? No. Oh, I can't do that. I'm making little marks on the paper. All right. So then the sample is 250, this little sample. And then the sample, or the P hat, the sample proportion is P hat, 58%. Shh, there they go again. Okay, now notice that these two are actually quite a bit off, right? And actually what you're trying to emulate, or what you want to get from a sample is you want it to be close to a population. So I don't know why this is. We just picked some random numbers just to go through the terminologies. But sometimes this happens. Hey, maybe right by the calculus class, there's a machine right by the door. All right, and maybe this is why this is a skewed sample. Okay, and that would be the best thing that I could say about that. Why that's so different. Okay, so we'll hopefully do better on the next one. I can't pause. This really drives me nuts. It said Control Shift F9 pauses the video. I hit it, nothing occurs. So I really don't know what's going on. So I'm going to hit it again. This is just a daily thing with this computer. I don't know. And to not be told if I'm paused or not is redonkulous. Okay, so now here's the next thing. In a sampling distribution, what is the mean? Well, here's the thing. I just said the president's approval rating. President's approval rating is 40% from the sample. So what's the average amount of people that don't approve of the president? 40%. So for a proportion situation, when it's listed that way, the mean is the proportion. And what we would like, even though it didn't really happen in the last one, we really hope that the proportion of the sample is approximately close to the proportion of the whole population, which we can never really know. So that's why the mean is P hat, because that's what we'll be dealing with. And then the next thing is, this is the standard error. This formula you need to write down and have this ready for access for your homework. So, have this ready for your access for homework and this. And then on the test, these formulas will be provided. So for today, you got to get this in a spot where you can find it, so you can, when you read a question where it asks, what's the standard deviation or the standard error, you pull this out. Now, I hope you're listening, because this again, this should not be a problem, and I shouldn't get an I don't get it on this and whatever. If 40% of the people approve of the president, what percent do not? 60. So p hat is 40. 1 minus p hat is 60. I'm not putting 1 minus 0.4. We should be able to figure that out. It's simple. And then I surveyed 100 people. Well, n is 100. It's a very simple thing to calculate. And all you have to read is the question asks, what's the standard deviation of this scenario? Or what's the standard error? You use this formula, plug in the numbers, and answer it. So if p hat is 0.54 and n equals 27, well, what this means is 54% of the people feel this way about something out of the 27 people that I surveyed. That's all that means, whatever they're talking about. Find the mean and the SE, standard error, or it could say standard deviation. Very basic, very simple. What is the mean? If you look at the top of my page that's in red, what is the mean of this scenario? 0.54. And then what's the standard error? Shove the numbers in the formula. P hat is 0.54. You can't put 54%. You got to do decimals when you throw them in the formula. And then what's the opposite of 54? What's the complement? 0.46. I just spit on the computer. I wish I spit in the keyboard and went, and oh, can I have my computer from 4 years ago, please? Because I can't pause. I'm sitting here like an idiot. Oh, here we go. And then this makes for a boring YouTube video. I should sing in the, like we're on an elevator. Is everyone ready? YouTube video of the year. Now, you should recognize the structure of this formula. Now that I think about it, those that do your homework and actually can, remember what they did and not a lot of you do your homework, but can you remember what was the beginning of a confidence interval? What was the first thing written in the last 2 days of homework? What was the first thing in our formula? No. Yeah. Huh? No, not Z star. That's the second thing after the plus minus. What's the first thing for a total confidence interval? The mean, which is labeled as what? X bar. But what's the mean of a proportion? It was on the last page. What's the mean of a proportion? I put it on my head here. I'll put this on my head. Okay. P hat. So actually we should make sense out of this. Has the exact same structure. The mean, are we listening? Plus or minus. You should probably just tape yourself saying it to save your voice, and then just press the button every time in class, like 5 times. I don't get it. 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 All right. And then remember what I said? I didn't tell you why. But this is a Z distribution. And then you just look at the bottom, to find the Z number. And then I kept this in green because this is called the standard error. By the way, I should get my pen again. I'm going to do this real quick. What does all of this represent? Don't say the standard error. That's green. What does all that represent from the past couple days? That's correct. Who said that? Nice. That's called the margin of error, which I have written on the next page. No, leave that. Okay. So here's the next question, which this is, I guess I'll read it since I have the time. I can't pause the video. He always complains. Suppose that 575 Americans are surveyed on the type of car they drive, and 201 said that they drive an American-made car. I think I could be a TV guy. Be one of those voice guys. Construct and interpret a 95% confidence interval for the proportion of American citizens that drive an American-made car. My voice is a little scratchy today. I could have done a better job on that. Okay, so your job is this. Okay, wait a minute. I don't get it. I don't get it. I don't get it. So how? What? Whoa. Oh, and then this is gonna be on a test. How do I know which type of question this is? Well, first of all, there's no standard deviation given, is there? Does it say anything about a standard deviation at all? I mean, I don't see how we could possibly screw this up. There's nothing said about that. And how I'm going to know this is a proportion? Suppose you survey this many people, and this many people did something out of that many people. It's a proportion. I don't know. I don't know what else I can tell you. I can't help you if you don't get that. Okay, so this is a proportion. I have a formula sheet. Now I'm talking about the test. Okay, so it's the one with the p's in it. P for proportion, or percent if you want. All right. So again, I'm trying to do globally as I teach every single section how to help you when it comes to the test. Okay, so now that I know what formula I'm dealing with, these are the letters I need. So what is n, everybody? Oh, I have to write now. Okay, so what's n? What is n? Oh my gosh. 575. What is P, or how do I find it? And I gotta leave the video for a minute. I want to get my sheets because I want to get my numbers, so I don't have to worry about students. Hey, can you calculate for that for me? They say, screw you, Mr. S. I'm back. All right. So what's P hat? How do I find it? 201 divided by 575. And again, I have no idea if this video is even going right now. And this is a 0.35. Confidence interval did they make you go by? 95%. And then what's your Z star? If you look it up. This is one of the, you might even remember this because this is the one they use the most. This is the one that's used the most. Okay, so I understand it's a proportion. Look at all the letters are covered for the formula that I have up there. So let's go for it. It's 0.35 plus or minus Z star 1.96. It's hard for me to write because I don't want to hit some buttons and it really discombobulates my whole computer. If 35% do, how much do not? 65. And then it's divided by n, which is 575. Okay, sorry for writing so. Actually, Lexi's a better writer than I am when I'm taking these notes here, writing these notes. 0.35 plus or minus, that's my 8-year-old. Then this number right here is, you should go one more decimal place, but I probably should go a little bit farther on this for precision. But now that I stopped at 0.305, you actually should go one more decimal just to, the more rounding you do, the less, you're getting less and less accurate. And then I don't know what's happening here. We got to make sense out of the scenario. But I'm getting some crazy answers from you guys, and I marked it on some of your sheets that I'll give back to you probably on Monday. But if the population's wrong, if the sample's percent's 35%, then the population, if the margin of error is only 0.03, then the population should be between these small margins. And some of you guys are putting like, okay, and then they put like, I get a negative 0.27 less than, by the way, what letter do I put here? Then don't write negative 0.27, that's wrong. What I'm saying is you guys are putting nonsensical answers down. I don't think you globally understand what we're doing. And you need to think about that as an honors student, what we're actually getting. We should have an interval that's close to the mean that we're dealing with there. In this case, it's 0.35. So I don't know if I'll be able to find the eraser. You know what? I'm not even going to try. I'm just going to do that. All right. So this number is 0.311. And that was just a little thing. Do I put mu here now? Or what is the parameter? Do I put mu here? Or what do I put? I just put P. That's the population's percentage of people that drive an American car. And then what do we do at the end? We write a sentence, which I have coming right here. We are 95% confident that the true proportion, what that all means is the proportion of all people, all Americans, should fall between 31.1% and 38.9%. So 31.9, approximately between 31.1 and 38.9% of all Americans should drive American cars. We have a 95% confidence level that we can say that. Okay, and then I'll sit here again and sing a song or something as I wait for people to catch the notes for this video that I don't even know if it's taping or not, which is a lot of fun. Oh, how's everything going? Good? Good. May I proceed? Nice little, I didn't sing. I know, I can't think of anything. Okay, now, this is not the formula, but somebody over there did say this. Hey, MOE, what does MOE stand for? Margin of error. That's, how you get your plus minus value. And all I want you to know is, for those people that have an algebraic mind a little bit, I always say the CAT students, but Math 3 has some good stuff too, and those that were good at that should understand what I say next. All you need to do to find a minimal sample size is use this formula right here and solve for n. So I'm just going to cover that. What would I do first? How would I get rid of that z star? What would I do? What would I do to get rid of z star so it's away from that side? Divide. So now we have MOE divided by z star. How would I free n from that square root? How do you get rid of a square root? You square. Okay, isn't n on the bottom? I got something crazy to say about this. Whatever you do to one side, just say it. Do to the other. So can't you just flip one side of the equation as long as you flip the other? I do that a lot in CAT as a, hey, I got the variable I need to solve for and it's on the bottom. Flip it, okay? And then after that, you should be able to see that you have to multiply both sides by the p stuff. P hat times 1 minus p hat. And how much do you have to understand of any of that? None of it. So don't say I don't get it. So divide by z star, that would have been MOE divided by z star. Square both sides, that's why we have the square. Flip, that's how z star is on top and MOE is on the bottom. Then on the other side, it'd be n over all the p stuff. Multiply both sides by the p stuff. That's why that's sitting out right here. Anyway, this will be given for you. And then I'll tell you, this, again, was on our video. I got to really pay attention next time I see this. Minimal sample size, I remember something like a 200 number. So we need a sample size of 214. And I think I kind of get it now. I get it where maybe you're an engineer, or maybe you made 100 light bulbs. And we want to have a certain margin of error for us to be confident that we can send the 1,000,000 light bulbs out and sell them at a certain confidence level. So how many light bulbs should I test to make sure I'm under these parameters? Does that make sense? So I think that's why this is important. All right, and then you can take it for what it's worth. Ultimately, you need to know how to do this. So does this question really emulate that? Not much. It's just let's practice the formula. So according to the American Pediatric Association, reading because I'm going to give the note takers a chance to write this down. 74% of the teenage boys are taller than 68 inches. Great. How large a sample must be taken to have a margin of error of 4% using a 99% confidence level? Lucky, that is on our sheet. So again, just imagine the light bulbs. You only have a certain margin of error at a certain confidence level to feel good about selling our 1,000,000 light bulbs. What sample size should I use to fit those parameters? And then go ahead and get that sample size and test them and see what actually happens. Okay, but again, this question is a little different. and I got to write again. Okay, so again, how do I know this is a proportion question? There's a dang percentage. A percentage of people do this. It's simple. I don't know what else I could say. So what is p hat? It's staring you in the face. What's p hat? 0.74. What's the margin of error? I can't help you if you can't convert these to a decimal. How many people will put 0.4? What is 0.4, everybody? 40%. I can't help you. You're seniors in this honors class. What's our confidence level? 99. What's the Z number that you have to look up? 2.576. Okay, that's what they have in that sheet. And then I'll just leave it at that, not talk about what happened last year, what I did last year. So I do need help on this calculation, although I think I kind of remember what the nice student last hour that does help me when I ask, hey, can you calculate that for me? Okay, 74% do, 26% do not. Not making rocket science out of the second part of the formula. Yeah. N equals, I think it's 797.995. Thank you. Another nice person. Okay, now what do we do for this? I think we round up because we want to go a little bit above, even if it said 797.3, I think we're supposed to go to 798. So I won't be a stickler about that, but I will be a stickler on other things where people are rounding wrong when they're supposed to round mathematically, especially when you're looking up Z-chart numbers and all that other stuff. When we get this amount of people, that's what we say there. And then I'm done, and I can't wait to see what happens here when I end this video, if there is a video at all. Okay, thanks for showing up, everybody.